Alright, welcome everybody. This is a quick rundown on a kruskal-wallis test. Kruskal-wallis uses more than one category, so you could have a group of 2, you could have a group of 10. So an example of this would be, say, by races. It would be multiple races. By gender, probably 2-ish genders. Anyway, you can do 2, you can do more than 2, and then you're dealing with interval or ratio data. Avoid ordinal data, and definitely avoid like categorical data. Not going to work. Okay, so in this case we are going to be using fields data, which is the soya data, and the soya data is examining the effect of soy consumption on sperm count. So we have 4 groups of soy dosages, which I'm going to paste for you just so you can see what they are. And so we've got none, at least 1 meal a week, 4 meals a week, and 7 meals a week. We're then going to compare that category, being 4 of those, with the outcome variable, which is sperm count, which is definitely going to be in the interval or ratio category. So step 1, pretty much always our step 1, we're going to go load our data. So this is the soya data, soya.dat. If I want to check that and make sure that it exists, there it is. And we really have 2 variables here, the amount of soy and the sperm count. Excellent. So we kind of want to look at this data here, and I can run a quick summary on that data and see how it's currently organized. So summary. Okay, and this is kind of problematic. We start with 1, 4, 7, and then no. That is not in an order that makes sense. We would rather have it start with no than 1, 4, 7. That lets us be able to run analysis that, more soy matters rather than each of these groups just being a separate group. So this is a real quick bit of code that says go take my soy variable and change its level, and this 4 represents the last variable, the no soya. So put that first, and then put what was currently first, second, what was second, third, what was third, fourth. So now when I summarize that again, I start with no, then 1, 4, 7. Alright, let's run some quick descriptive statistics, because, as I've said numerous times, always good to do descriptive stats. Just to be clear, I am using a library here, so if you haven't loaded the library for that, it will throw an error. You should look up which library it is and grab it. So just to tell you, if I can, I lost my libraries. Okay, well, Pastix is the library that uses that. So if, just as a note, yeah. Anyway. Okay, so we went through and sorted this out. At none, we have our normality test. Normality is violated pretty much all the way across the board except for 7. That would put us pretty handily in our non-parametric tests, which is where we are. And if I want to, I could run this again with descriptive as true and get my means, because it's kind of nice to see averages. So my average for none is 4.9, then 4.6, then 4.1, and then 1.6. So as a trend, it does appear to be going down, though not by a lot, and then it really drops off at this 7 level, which we're going to be testing. Okay, so now that we've done that, I'm going to hit Control 11 to just clear my screen, because there was a lot of stuff there. Come back to it later. Alright, and somebody needs to use a leaf blower. Hopefully that doesn't come through on the video. Alright, so we just did that. We can also run a Levine test on our data. We just did that and kind of showed that our significance was when we did the by and they violated, and then just as a total they also violate. So there's 2 reasons to really be using parametric tests. Alright, the kruskal test is actually a really simple command to use. Kruskal.test. You take the number that your variable is, in this case sperm, by the group that you have, in this case soya, and here you can just tell it what your data soya is. Now if you wanted to, you could have typed this like this. It will do the same thing. That says the variable sperm owned by soya data by the variable soya owned by soya data. Doesn't matter, same numbers, same answer. And in the end, the exact same number of characters. Your call. Okay, so now that we've done that, we know that there is a significant difference between these groups. So that's great, but we don't know which groups are significantly different from each other necessarily. I'm then going to load in a library called Pyjamas. Now I've already loaded that, I think, so I'm just going to comment, but you would want to. And then run a multiple comparison test. Okay, so the multiple comparison, this is where it was really nice to make the none our first variable, because that's what makes it the comparison. None versus 1, none versus 4, none versus 7. That's a reasonable comparison. If we hadn't refactored before, we'd have had 1 versus none, 1 versus 4, and 1 versus 7, which wouldn't have shown anything significant and doesn't really make sense. You have a baseline here. None should be compared to everything else. Anyway, we can just look over here and be kind of lazy, and the one that says true is the one that's substantially different. So nothing is different than 7. That's the only thing that is significant. So we can say 0, 1, and 4, probably not a big deal. If you're doing 7 soy a week, it may have an effect on your sperm count. That's the end of that.